Part 1. Introduction. The question that defies eternity before the stars ignited their first fires, before space stretched out its infinite canvas, before the very concept of time began to tick. There lies a question so profound, so audacious, that it doesn't merely challenge the boundaries of science, it dares to unravel the fabric of meaning itself. Welcome back to Forgotten Cosmos. Today, we venture into a question so profound, so mind-stretching, that it bends the very fabric of time itself. What was there before the Big Bang? It sounds simple at first, but the deeper we go, the more it challenges everything we think we know about time, space, causality, and even existence itself. In this video, we'll explore what modern science says, what quantum theory whispers, what fringe thinkers speculate, and what ancient minds dared to imagine. From the limits of cosmology to the metaphysical edges of philosophy, this journey will not give you all the answers, but it may change the way you look at the universe forever. So, fasten your mind. This isn't just a trip to the beginning of time, it's a journey beyond beginnings. What was there before the Big Bang? To most, the Big Bang is the ultimate origin story, the singular moment when the universe burst into being, a cosmic spark that birthed space, time, matter, and motion in one unfathomable instant. It's the starting line of everything we know, the point where the laws of physics as we understand them took root. But to ask what came before is to step into a realm where logic falters, where intuition stumbles, and where the very notion of before becomes a paradox. Science tells us that time itself was born in the Big Bang. There was no before in the way we imagine, no endless void, no silent clock counting down to creation, not even a vast emptiness waiting to be filled. The concept of nothingness, as we try to grasp it, doesn't quite fit either. It's not a blank page or a dark room. It's something stranger, something beyond the reach of human imagination. And yet, despite this, we cannot stop ourselves from asking. Why? Because we are human. We are creatures of stories, of beginnings and endings, of causes that lead to effects. The idea of a universe without a before feels like a book with its first chapter torn out, an unfinished puzzle that tugs at our curiosity. Our minds rebel against the notion of a beginning without a precursor, a creation without a cause. This question, this relentless need to know, is not just a scientific pursuit. It's a deeply human one, woven into our desire to make sense of existence itself. This tension between what we know and what we long to understand has sparked some of the most breathtaking ideas in science and philosophy. What if the universe emerged from a fleeting quantum fluctuation, a ripple in the fabric of nothingness that exploded into everything? What if our Big Bang was merely one chapter in an eternal saga of cosmic cycles, where universes expand, collapse, and are reborn in an endless dance? Or perhaps our reality is just one bubble in a frothing multiverse, where infinite realms collide in higher dimensional spaces, each birthing its own cosmos. Could it be that the laws of physics themselves, those seemingly unshakable rules that govern our world, are not fundamental but emergent, arising from a deeper, stranger truth that lies beyond our grasp? As we embark on this journey, we will explore these possibilities not as definitive answers, but as doorways into the unknown. Each idea is a thread in a tapestry of wonder, pulling us closer to the edge of what we believe is possible. Some paths may lead to revelations about the universe. Others may reveal the limits of our questions themselves. Because sometimes, the question is not a barrier to understanding. It is the mystery that drives us forward, the spark that lights the way. In the chapters to come, we will follow these threads, weaving through science, philosophy, and imagination. We will confront the enigma of a universe that may have no beginning, and in doing so, we may discover that the act of asking, boldly, fearlessly, is what makes the mystery worth chasing. Part 2. The Edge of Time, Unraveling the Cosmic Origin. The Big Bang is often painted in our minds as a cataclysmic explosion, a fiery blast that hurled stars, galaxies, and matter into a vast, waiting void. But this vivid image is a mirage. The Big Bang wasn't an explosion in space. It was the birth of space itself. It didn't erupt into a pre-existing emptiness. It was the rapid unfurling of space-time, a cosmic unfolding that created the stage on which all existence plays out. Imagine not a bomb detonating, but the very fabric of reality stretching, expanding, coming into being in a way that defies our everyday intuition. According to Einstein's general relativity and the standard model of cosmology, this extraordinary event began approximately 13.8 billion years ago. But here's the twist. This wasn't just the birth of matter or galaxies. It was the birth of time itself. In the equations that describe our universe, the Big Bang is time's starting line, the moment where t equals 0. There is no before in this framework, no endless stretch of time leading up to the cosmic dawn. Time, as we know it, emerges alongside the universe, woven into its very fabric. To ask what came before is like asking what lies south of the South Pole, as Stephen Hawking famously put it, a question that collapses under its own weight, because it assumes a direction that simply doesn't exist. This isn't just a philosophical musing, it's a cornerstone of modern cosmology, backed by compelling evidence. We see the universe expanding today, as distant galaxies drift apart, their light stretched into the telltale redshift that reveals their retreat. The cosmic microwave background, a faint whisper of radiation that bathes the cosmos, offers a glimpse of the universe just 380,000 years after its birth, a snapshot of a searingly hot, dense cosmos cooling into the seeds of stars and galaxies. These observations align beautifully with the model of an expanding universe that began in an unimaginably compact, energetic state. Yet this model, as robust as it is, has its edges, places where it frays and leaves us grasping. As we trace the universe's history backward, approaching that pivotal moment of t equals 0, the math begins to unravel. Density and temperature soar toward infinity, converging on what physicists call a singularity. This isn't a physical place or object, but a point where the equations of general relativity break down, refusing to describe what happens next, or what came before. The singularity isn't just extreme, it's a boundary where our understanding of space, time, and physics itself falters. It's as if the universe holds up a sign that reads, "No further answers here." This limitation has sparked intense curiosity and debate. General relativity is a masterful guide to the cosmos we observe, but it's silent on the birth of space-time itself. What happens when the universe is so compressed, so extreme, that the rules we know cease to apply? Some physicists argue that to peer beyond this veil, we need quantum mechanics, the strange, probabilistic world that governs the subatomic realm. Quantum theory might offer clues about how time and space could emerge from something even more fundamental, perhaps a realm where the very concept of beginning is redefined. Could time truly have a starting point? Could something, everything, emerge from a state where the laws of physics as we know them dissolve? Or are we mistaking a flaw in our mathematical models for a true boundary in reality? These questions don't just challenge our science, they force us to rethink the nature of existence itself. If time began with the Big Bang, then our notions of cause and effect, of origins and endings, must be reimagined from the ground up. The edge of time isn't just a scientific frontier, it's a mirror reflecting the limits of our understanding and the audacity of our curiosity. In the chapters ahead, we'll dive deeper into these mysteries, exploring the radical ideas that attempt to bridge the gap between the known and the unknowable. From quantum fluctuations to cyclic universes, each possibility invites us to stretch our minds further, to question not just what came before, but whether before is even the right question to ask. Part 3. Quantum Origins. When nothing teems with possibility. The classical picture of the Big Bang often leaves us at a silent precipice, a mathematical boundary where time, space, and matter seem to vanish into an impenetrable void. Science, in its classical form, has little to say beyond this point, as if the universe's origin is a locked door with no key. But quantum theory offers a different perspective, one that challenges our intuitive sense of nothingness. In the quantum realm, nothing is far from empty. It's a dynamic, restless sea of potential where the very concept of absence is rewritten. In everyday language, we imagine nothing as a complete void. No particles, no energy, no space, no time. Just an absolute absence. Yet, quantum field theory paints a radically different picture. The quantum vacuum, the lowest possible energy state of any system, is not a barren wasteland. Instead, it's a vibrant, fluctuating tapestry woven from quantum fields. These fields, which permeate all of space, are never truly still. They hum with activity as particles and their antiparticles briefly flicker into existence before annihilating each other, only to reappear elsewhere in an endless dance of creation and destruction. This is not a poetic metaphor, but a measurable reality, a foundation of modern physics that reshapes how we think about emptiness. The evidence for this restless vacuum is not confined to theoretical musings. It's observable in the physical world. Consider the Casimir effect, a striking phenomenon where two uncharged metal plates placed close together in a vacuum experience a subtle but measurable attraction. This force arises because the quantum vacuum is not uniform. Its fluctuations create waves of energy, and only certain wavelengths can fit between the plates, leading to an imbalance that pushes them together. Similarly, Hawking radiation, the process by which black holes can slowly evaporate, relies on the quantum vacuum's ability to produce particle-antiparticle pairs near a black hole's event horizon. One particle falls in, while the other escapes, carrying energy away and causing the black hole to shrink. These phenomena are not mere curiosities. They are tangible proof that the vacuum is anything but empty. So, what does this mean for the origin of the universe? If nothingness is this lively, could it hold the key to how everything began? In 1973, physicist Edward Tryon proposed a provocative idea that turned heads in the scientific community. Perhaps the universe is simply one of those things that happens from time to time. His hypothesis was daringly simple, yet profound. The universe might be a quantum fluctuation, a fleeting bubble of energy that spontaneously emerged from the quantum vacuum. In this view, the universe's total energy could be zero, as the positive energy of matter is perfectly balanced by the negative energy of gravitational attraction. This balance means that no physical laws are violated. The universe could, in theory, pop into existence without needing an external spark. It's a tantalizing thought. Our vast cosmos, with its galaxies, stars, and planets, might be a cosmic accident, a momentary ripple in an infinite sea of possibility. This idea has since evolved, with physicists like Alexander Vilenkin refining it through the concept of quantum tunneling. In this model, The universe doesn't just bubble up randomly, but tunnels from a state of pure nothing into existence, guided by the probabilistic rules of quantum mechanics. Picture a particle trapped behind a barrier it shouldn't be able to cross. Quantum tunneling allows it to slip through, defying classical intuition. Similarly, the universe might have tunneled from a formless, timeless state into the expanding space-time we know today. It's a compelling image. Our reality, born not with a bang, but with a subtle quantum leap. Yet, even these elegant models leave lingering questions, like shadows cast by a flickering flame. The quantum vacuum, for all its dynamism, is not truly nothing. It's a structured entity, governed by physical laws, and imbued with the potential for fluctuations. If the universe arose from such a vacuum, we must still ask, where did this vacuum come from? What established the quantum fields and their governing principles? And what of time itself? For a fluctuation to occur, does time need to pre-exist as a stage for the event? Or does time emerge alongside the universe, woven into its very fabric? These questions push us to the edge of physics and into the realm of philosophy, where language and intuition begin to falter. This leads to an even deeper mystery. Is the quantum vacuum truly fundamental, or is it merely a layer resting on something more abstract, something we have yet to grasp? Some physicists speculate that the vacuum might emerge from a deeper mathematical or geometric framework, perhaps tied to string theory or other speculative models that describe reality at its most fundamental level. If so, the quantum vacuum might not be the ultimate nothing, but a kind of intermediary state, a bridge between true nothingness and the universe we inhabit. In this quantum perspective, the Big Bang is not a hard boundary, but a phase transition, akin to water freezing into ice or steam condensing into liquid. The universe may have crystallized from a primordial state, not from absolute nothing, but from something so alien to our experience that it defies description. This view challenges the very notion of nothingness, suggesting that nothing is not a void, but a realm of infinite potential, structured by laws we are only beginning to understand. The implications are both humbling and exhilarating. If the quantum vacuum is so rich with possibility, perhaps the question isn't what came before the Big Bang, but what gave rise to the rules that allowed it to happen. Are we searching for the origin of the universe itself, or are we chasing the deeper mystery of why the laws of physics permit such a universe to exist at all? In this restless quantum sea, nothing is anything but silent. It whispers of origins, possibilities, and questions that beckon us to keep exploring. Cycles, multiverses, and the dimensions. Beyond. The question of whether the universe had a singular beginning inevitably leads to another. Must it also face an end? Or could it be part of an eternal process, cycling through creation, collapse, and rebirth in a rhythm that defies the very notion of a first moment? For millennia, philosophers, mystics, and scientists have grappled with this enigma, and today's cosmology transforms these ancient musings into bold, testable hypotheses that stretch the boundaries of our imagination. One of the most captivating ideas is the cyclical universe model, which challenges the notion of a one-off Big Bang. Instead, it envisions a cosmos that expands outward in a blaze of creation, cools and stretches over billions of years, then contracts in a cataclysmic Big Crunch, only to ignite once more in a new Big Bang. This cycle could repeat indefinitely, each phase a fleeting chapter in an infinite saga. Remarkably, such ideas echo ancient cosmologies, like those in Hindu philosophy, which described the universe as oscillating through vast epochs of creation and destruction. Modern physics breathes new life into this vision, with models grounded in general relativity suggesting that the universe's geometry could allow for such a cosmic pendulum, swinging between expansion and collapse. Among these cyclic models, the ekpyrotic universe, proposed by physicists Paul Steinhardt and Neil Turok, stands out for its audacious creativity. Drawing from the framework of string theory, it imagines our universe as a three-dimensional brain, a kind of membrane, adrift in a higher dimensional space. This brain is not alone. It floats alongside others in a vast, unseen cosmos. Every so often, our brain collides with a neighboring one, unleashing a surge of energy so immense that it manifests as what we perceive as a Big Bang. In this view, the Big Bang is not the absolute origin of everything, but a recurring event, a fiery crescendo in an eternal symphony of cosmic collisions. This model reframes time itself, suggesting that our universe's timeline is not a straight line, but a loop, extending infinitely backward and forward, with no true beginning or end. Then there is the multiverse hypothesis, a concept even more mind-bending in its scope. Rather than a single universe with a singular origin, reality might be a sprawling tapestry of countless universes, each governed by its own unique physical laws and initial conditions. One version of this idea stems from eternal inflation, a theory proposed by cosmologist Alan Guth and others. In eternal inflation, the rapid expansion of space, driven by a field called the inflaton, never fully stops. While some regions of space settle into stable universes, others continue to expand, spawning new bubble universes in an endless cascade. Our universe, with its familiar laws of physics and constants, fine-tuned for stars and galaxies, might be just one such bubble, floating in an infinite sea of other realities, each with its own distinct properties, some hospitable to life, others utterly alien. String theory offers another avenue into the multiverse, introducing the possibility of extra dimensions beyond the four we experience, 3 of space and 1 of time. In some versions of string theory, reality could encompass up to 11 dimensions, most of which are compactified, curled up into scales so tiny they're invisible to our instruments. Our universe might be a 3-dimensional slice through this higher dimensional landscape, coexisting with other slices like pages in a cosmic book. A collision between 2 such slices could spark a Big Bang-like event, creating a new universe without requiring a traditional beginning. This idea transforms our understanding of origins, suggesting that what we call the Big Bang might be a local phenomenon, a ripple in a far grander, multidimensional reality. Yet, these dazzling theories come with a significant challenge. They are extraordinarily difficult to test. If other universes exist, they may lie beyond our observational reach, separated by barriers of space, time, or dimensionality. If extra dimensions are real, their compactified nature makes them elusive, detectable only indirectly through their influence on fundamental forces or particles. Critics argue that these ideas, while mathematically elegant, flirt with the boundaries of science, verging on speculation because they lack direct empirical evidence. Proponents counter that these models are grounded in rigorous mathematics and could, in principle, yield testable predictions, perhaps through subtle imprints in the cosmic microwave background or anomalies in particle physics experiments. These cyclic and multiverse models offer provocative answers to the question of what came before the Big Bang. In many of these frameworks, the notion of before becomes irrelevant. There is no singular origin, only an elsewhere, other universes, other dimensions, or other cycles. Time itself might be a local phenomenon, specific to our universe or brain, with the broader reality existing in a timeless or cyclical state. What if our universe is merely one frame in an eternal cosmic film, each cycle a beat in a heartbeat that never ceases? Or what if the origin we seek lies not in the flow of time, but in the geometry of hidden dimensions, folded into realms we cannot yet perceive. These ideas push the frontiers of human understanding, forcing us to confront the possibility that our universe is not a solitary entity, but part of a far vaster, stranger reality. The Big Bang, once thought to be the ultimate beginning, may be just one event in an infinite tapestry, a single note in a cosmic melody that resonates across dimensions and eternities. As we probe these possibilities, we are reminded that the quest for origins is not just about finding a starting point, but about glimpsing the grandeur of a reality that may be far less alone and far more interconnected than we ever dared to dream. Part 5. Conclusion: the mystery as the heart of meaning. So, what existed before the Big Bang? This question, deceptively simple yet profoundly complex, lingers like a whisper from the cosmos itself. As we've journeyed through the frontiers of human understanding, we've encountered the limits of classical physics, where time itself seems to emerge at t=0, a singular point where the universe's story begins. We've delved into the strange realm of quantum mechanics, where nothingness transforms into a vibrant sea of fluctuating possibilities, virtual particles dancing in and out of existence, defying our intuitive sense of emptiness. We've explored speculative landscapes, cyclic universes reborn in endless loops, cosmic membranes colliding in higher dimensions, and multidimensional frameworks, where our Big Bang might be just one spark in an infinite cascade of creation. Each perspective, rather than pinning down a single truth, has woven a richer tapestry of questions, deepening our appreciation for the universe's enigma. Mainstream science, with its rigorous insistence on evidence, offers no conclusive answer. Many physicists argue that the question itself is a misstep, a category error, like asking what lies north of the North Pole or what note comes before the first chord of a symphony. In this view, the Big Bang is not an event within time, but the very origin of time, space, and causality. The concept of before simply has no meaning, because the framework that allows for before was born in that fiery moment of cosmic inception. It's a clean, elegant solution, one that ties the universe's beginning into a neat knot. Yet, for all its logical beauty, this explanation leaves a quiet ache in the human spirit. We are not merely equations or data points. We are creatures of narrative, driven by an innate need to trace stories back to their roots. The idea that there is no before feels like a door slammed shut, denying us the opening chapter of existence. This tension, between the precision of science and the yearning of the human heart, fuels our relentless curiosity. It's why we keep asking, even when the answers elude us. This persistent questioning is not futile, it's the engine of progress. Every cornerstone of modern cosmology, quantum theory, general relativity, the Big Bang model itself, began as a spark of speculation, an idea dismissed as fringe before it reshaped our understanding. The question of before the Big Bang may one day follow the same path. Perhaps a future breakthrough, born from some yet unimagined theory or observation, will reframe the mystery as a puzzle with a solution. Perhaps we'll discover that our universe is but one bubble in a frothing multiverse, or that time loops back on itself in ways we cannot yet fathom. Or perhaps the answer will remain forever out of reach, not because it's unknowable, but because it demands a perspective we haven't yet learned to adopt. And maybe that's the point. Maybe the true value of this question lies not in finding a definitive answer, but in the humility it evokes, a reminder that, despite our towering achievements, we are still small beings in a vast, unfolding cosmos. The mystery of the Big Bang's before invites us to stand in awe, to marvel at a universe that is both knowable and unknowable, familiar and utterly alien. It challenges us to embrace wonder as a companion to knowledge, not its adversary. In the end, the beauty of this question lies in what it reveals about us. We, fragile specks on a pale blue dot orbiting an unremarkable star, dare to gaze into the infinite dark and ask, where did all this come from? In that act of asking, we weave ourselves into the timeless fabric of the universe. We become more than matter and energy. We become vessels of curiosity, carriers of questions that echo across generations. And in that endless pursuit, we find not just the universe's story, but our own. Thank you so much for watching this cosmic journey with us. If you enjoyed diving into the mysteries of the universe, don't forget to like, subscribe, and hit that notification bell to catch our next video. Stay curious, and we'll see you in the next adventure.